In this video, we solve problem 9.2.044 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to consider the following repeating decimal, and it's 0.6191919, and there are infinitely many 19s. First, we're asked to write the repeating decimal as a geometric series, and we're given a constant plus the sum as n goes from 0 to infinity of something times something to the n. That's usually represented by a, and that's usually represented by r. Excuse me. It's the the common ratio of the geometric series. And then we're asked to write the sum of this series as the ratio of two integers. It's easiest to write this if we think of this as consisting of two parts. We've got that 0.6, and then we've got the repeating part. So I would think of it this way. This is 0.6 plus 0.019, 19, and so on. And that 0.6, that can go in that box right there. Or you can call that 2/3 if you prefer. And then this can be written as a geometric series because this 19 is in the thousandths place. So that represents 19 over 1,000. And this 19 is in the, hundred thousandths place. And then the next one, we add 2 zeros every time. So there was 3, and now there are 5 zeros, and now there should be 7 zeros. Oops, there we go. And so on. Okay. So that represents a 19 over 1,000. That represents 19 over 100,000. That one represents 19 over 10 million, and so on. We just keep going. So the first term here, that's our A. And then we multiply by 1 over 100 to get from term to term. So that's our R. We multiply that by 1 over 100. That's our R. And so this is the sum as n goes from 0 to infinity of the first term times that common ratio raised to the nth. And the first term is 19 over 1,000. And the R value is 1 over 100. So you can write it this way. This is one version of the answer. If you want, you could write this as a fraction, or you could write either of these as decimals as well. I think I'll keep them as fractions though. Okay, so that's that part. And now we're asked to write the sum of the series as a ratio of two integers. Well, according to our formula for geometric series, the sum as n goes from 0 to infinity of a times r to the n converges to the first term over 1 minus the common ratio, provided that the absolute value of r is less than 1. Otherwise, it diverges. Now, in our case, the absolute value of r is 1 over 100, so that's true. This series does converge to a number, and it converges to this number right here, this repeating decimal. In order to write that as a fraction, though, I can substitute r equals 1 over 100 right here, and I can substitute a equals 19 over 1,000 up here. Now, that is only going to take care of this part, and then we have to add 3 over 5 to it. It's actually not too bad at all. We've got the sum as n goes from 0 to infinity of 19 over 1,000 times 1 over 100 raised to the n is equal to 19 over 1,000, all divided by 1 minus 1 over 100. Now, I can write this 1 as 100 over 100. So I've got 100 over 100 minus 1 over 100 is 99 over 100. And if we multiply by the reciprocal, we leave this one alone, we take this one, we flip it and multiply. This is what we get. So we'll have a 10 left there and the 100s reduce and we end up with 19 over 990. And that does not simplify. So that is just this series part. I need to add that 3/5 to this. So we'll have 3/5 plus 19 over 990. If you want, you can find out, you can get a common denominator. 5 times 198 is 990. So I'll multiply this fraction by 198 over 198. So we have 198 times 3 plus 19 in our numerator. And the denominators are the same. They're both 990. Let's see if that simplifies in my calculator. I've got 613 divided by 990. And it doesn't seem to simplify. So I think that's it.